In this video, we are interested in looking for the value of y that makes this equation to be true. Now we have y plus 5 equals to y. So what values of y that is going to make this equation to be true? To do this, the first thing we have to do, because let's take for instance, let's have a case 1. If you say that we have y minus y equals to -5, by moving this to the side, this is going to be 0, which is not equals to -5. So this approach is not feasible. Now let's look at case 2, which is going to be the best approach. That is, we have y plus 5 equals to y. Square both sides. Okay, so in the next slide, we have y plus 5 squared equals to y squared. This can be written as y plus 5 equals to y squared. Now, distributing this here, we have y squared plus 10y plus 25 equals to y squared. Now, moving this to the other side, here we have y squared minus y squared plus 10y plus 25 equals to 0. So y squared minus y squared cancel out. So here we have 10y plus 25 equals to 0. And here we can have 10y to be equals to -25. Dividing both sides by the coefficient of y, which is 10, then we can say y equals to -25 over 10, which can further be simplified to -5 over 2. But there's a need to check. So now we want to check that y plus 5 equals to y. And recall that we have the value of y to be -5 over 2. So here we have -5 over 2 plus 5. We want to confirm if this is truly -5 over 2. So finding the LCM of this, which is the common denominator, here we have -5 plus 10. We want to see if this is -5 over 2. So by solving this, we have 5 over 2, which is not equals to -5 over 2. So we can also conclude that no real solution for this problem. We've confirmed using the linear approach, and we can see that the left hand side is not equal to the right hand side. Also confirm using the quadratic approach, which shows the same thing. Thank you very much for watching. Please don't forget to subscribe. See you next time. Bye.